So in this new video, we are going to discuss about carbon steel pipes. What is the project specification? So uh, we are asking for Hyundai RL. Our grade is API 5L X52 PSL2. What is this PSL2 and X52? We already discussed 52,000 PSI. That is the uh, specified minimum yield strength of this grade. So what are the diameters we are using? Diameter 800, 900, 1200 and 1600. And the pipe beveled this is beveled, pipe is beveled or plain with wooden protectors for shipping. So this is the first slide. So next we will discuss this one already discussed. Now we will discuss CS01A. So the second slide here, CS1A. So CS pipes, pipe finish. What is in the specification? Internal station FBE coating, fusion bonded epoxy. It is 500 micron DFT, external 3LPE. These two coatings we will discuss later. So that is the second slide. So third slide about the equivalency of a API 5LX52. For ASME equivalent is ASTM A1024 or A1024M. What is this M? M means metric. So it is also equivalent to ISO 3183 3183 L360. So what is this API 5L X52? It is a specific grade of pipe from the petroleum American Petroleum Institute for Conveying Fluids. ASME is American Society of Mechanical Engineers. ASTM is American Society of Testing and Standards. And ASTM A1024 is the specification for carbon steel welded and seamless pipes. And it is considered equivalent to, so it's also equivalent to ISO 3183 L360. So now we discussed what is this seam difference between weld seamless pipe and welded pipes. So this is the difference between seamless and welded pipe. Seamless pipe is made from solid steel billet without any welding. So this steel billet, it is pierced and rolled into a hollow shape. And welded means by forming a flat steel plate into the cylinder, forming a flat steel plate into a cylinder, and the seams are welded. So it is most cost effective for lower pressure applications, while the this seamless pipes results in a stronger, higher pressure pipe. The welded pipes have a potential weak point at the seam, making it less resistant to corrosion stress in high pressure situations, whereas seamless pipes are more uniform and durable for critical uses. So cost is more expensive due to complex manufacturing process for the seamless. More cost effective due to simpler production. Availability generally available in shorter lengths. It can be manufactured in longer continuous lengths. Best for high pressure, high temperature critical applications like oil, gas and chemical industries. While these welded pipes are low pressure, structural, less demanding applications where cost is a factor. So I'm going to copy it into a photo. Now we will discuss how CS pipes are grouped. So CS pipes are grouped. This is a ASTM A1024 carbon steel pipe. So why it is grouped into P number, group number, and F number and A number? It is to standardize and streamline. Standardize and streamline the welding procedure and the performance qualifications according to the codes like ASME Section IX. This grouping, what will achieve? It will reduce the need for costly and time consuming individual testing of every specific material and the filler material combination. So there is a welding is what? It's a combination of specific material and filler material combination. So this combination not need to be tested for each and every specific material, because it is a costly and time consuming, so we need to avoid it. And so for achieving this uh, this not to avoid the need for costly and time consuming individual materials, we are grouping these materials. So to standardize and streamline welding procedure. So what are the, how it is grouped? It is grouped by P number, group number, F number, and A number. So what is P number? So the P number is assigned to base materials like carbon steel pipes. It is assigned to the materials that have similar chemical combination, mechanical properties like tensile strength, and most importantly, comparable welding characteristics. So this P number 1, P number materials with the same P number has a similar chemical combination, similar mechanical properties like a tensile strength, and similar weldability characteristics. So while qualifying a welding procedure in one material within a specific P number, that procedure is generally considered qualified for all other materials with the same P number, subject to other variables. It greatly reduces the number of required qualifications. So we have a material, we have a P number 1, like a carbon steel. So so these materials, so if it is qualified by one WPS, welding procedure, then that procedure is generally considered qualified for all other material within that same P number group. So what are the other base metal which have the same P number that we will see now? So what are the materials have the same P number as carbon steel? It is P number 1. No other material share the same P number as a carbon steel. P number groups with base metals with similar welding characteristics. So materials with different combinations are placed in their own P numbers. For example, P3 P3 include half chromium and half molybdenum steels, but P4 includes 1.5 chromium 1 and 1/4 chromium mobilium steels. P number 1 is exclusively for carbon steels. See, such low alloy steels include P3, P4, P5A, etc. And the stainless steels is a P6, P7, P8, etc. Non-ferrous material like aluminium, nickel, and copper alloys are also in the different P number ranges. For example, here, see the table QW QB 421.2 base metal assignments. It in the info.think.ca.com. Here, what you can see, it is for ASME Section 9 actually. So, carbon manganese steel have they have 4 group numbers within the same P number 1. P number 2 is not used. P number 3 is a half molybdenum or half chromium and a half molybdenum only. 3 group numbers. So 4 is a half, 1.5, 1 and 1/4 chromium and half molybdenum. Two group numbers. 5 is so where is 6 stainless steel. Martensite stainless steels grade 410, 415, 429. It has 6 group numbers. And ferrite stainless steels grade 409, 430, etc. Then austenite stainless steels. They have grouped again group number 1, 2, 3, and 4. Non-ferrous materials like aluminium, nickel, and copper alloys are also in different P number ranges. So stainless steel, aluminium. So P number 22 is aluminium. Aluminium 500 5000 series, 6000. So, like we discussed, P numbers we discussed already. It is assigned to base metals depending upon the chemical composition, mechanical properties, and the other weldability characteristics. So P number 1 is assigned to carbon steel type. Other, so that is the so this is a list of P numbers 1, 2, 3. 2 is not assigned. 3 is for molybdenum or chromium alloys like that. So this is for steel, stainless steel, P number 6, 7, 8, and down, like that. So this is the P number for it is for paste material, A number for well deposit chemistry, and F number is for filler material. This G number is within the P number. This is a subgroup of P number. So function of P numbers is that so if our material has a specific P number, that procedure is welding procedure is generally considered qualified for all other materials within the same P number group, subject to other variables. This greatly reduces number of required qualifications. Now group number. Group number are further subdivision of P numbers, specifically for ferrous-based metals like carbon steels. This grouping is used for construction code like requires impact toughness testing. Materials within the same pay number might have different toughness properties. So group number ensures that materials requiring impact is welded with the procedure specifically qualified for these requirements. For our PSL2 material, see, so the PSL2 material, it falls under group 1. It's a carbon with the P number category, but PSL2 designation for means that there are stricter requirements than PSL1, particularly concerning the chemical combination, like a carbon equivalency, impact mechanical properties, including impact testing and mandatory non-destructive testing. These requirements do not change the P and group numbers, but making the welding qualification process more rigorous. For instance, Charpy impact testing is mandatory for API 5L X52 PSL2, but it is not mandatory in PSL1. So what is Charpy impact testing? Charpy impact test measures a material toughness. What is toughness? It is ability to absorb energy before fracturing under sudden impact, particularly at lower temperatures. So its ability to absorb energy before fracturing under sudden impact. So it is mandatory for APL 5L PS2 to ensure pipes integrity and safety in demanding operating environments. It involves because this operating environments involves varying temperatures and high pressures. So what is this principle? This standardized specimen. It is a 10 mm, 10 mm and 55 mm specimen. It will have a V notch in the center. It is prepared from the material. This notch concentrates the stress at a specific point, simulating potential defects or cracks. The specimen is cooled to a specified test temperature. For API 5L, it is often 0 degree. A heavy pendulum hammer. Pendulum hammer is released from a fixed height to strike back at the notch specimen. The energy as absorbed by the specimen is measured by calculating the difference between hammer's initial potential energy and its potential energy after fracturing the specimen. Result in interpretation: a tougher, more ductile material absorbs more energy, shows a dull, fibrous fract surface, and brittle structure absorbs less energy and displays a bright crystalline fractal structure. The test helps to determine the ductile to brittle transition temperature. Ductile to brittle transition temperature of the material, a critical factor for cold weather applications. Why it is mandatory for PSL2? So PSL2 is very more stringent. Mandatory Charpy impact testing is a key component. Because the pipes transfer hazardous fluids like hydrocarbons and high temperature, Charpy ensures the pipe can withstand sudden impacts and shocks. So to reduce the risk of catastrophic brittle fracture, especially in cold environments. Performance in extreme conditions. Pipe operates in regions with low temperatures. Steel's toughness decreases as the temperature drops. Charpy impact verifies that pipe maintains adequate toughness at or below its expected minimum service temperature. Stricter quality assurance. PSL2 requires include tighter chemical composition limits and mandatory non-destructive testing in addition to impact testing. This comprehensive approach provides a higher level of confidence in the material's integrity compared to PSL1 where impact testing is not required. Weld integrity. For welded PSL2 pipe, Charpy is performed on the weld seam and the heat affected zone in addition to the pipe body. It ensures the entire body pipe structure can resist the impact failure, not just the base material. And the compliance of specified services. Major pipeline and regulatory bodies like require PSL2 for their projects to meet the stricter service requirements and safety standards. Now we discuss group number. Group numbers are like further subdivisions of uh, P numbers, especially for ferrous based material like most carbon steels. The grouping is used for like a construction code requires impact toughness testing. Materials within same P number might have different toughness properties, so the group number ensures that the materials requiring impact tests are welded with procedures specifically qualified for these requirements. So group number 1, the impact testing is required. In this video, we will continue with the group number. So, group numbers are the subset of B group, okay, or subdivision of B numbers, especially for these ferrous-based materials like carbon steel. So, this grouping is used when a construction code like BS31.3 requires impact toughness testing. So toughness testing we already discussed in the impact testing, Charpy impact testing. So some materials may require impact toughness testing. So within this P number, it is subgrouped into group numbers. Materials with the same P number might have different toughness properties. So the group number ensures that material requiring impact testing are welded with the procedures specifically qualified for the requirement. So, like we discussed here, we have the P number 1 is meant for carbon steel pipes, and it has grouped into 4 group numbers. Group number 1 belongs to low strength carbon steels, approximately up to 65 KSI. KSI means kilo pounds per square inch. This is the 1000 PSI. So, therefore, 65 KSI means 65 into 1000 PSI. Okay. So second group is for medium strength carbon steels. Third one for higher strength carbon steels, and fourth group belongs to other carbon steels. We have the group 1. Group 1 requires impact testing also. So these are different carbon steels are grade S36. That is structural steels. Then it is under P1 actually. That means all carbon steels are under P1. SA10 is grade ABC is for seamless pipe. SA153 is for pipe. SA105 is for forging, flanges, etc. Typically group 2. SA516 grade 70 is also pressure vessel plate. SA234 grade WPA. WPC is rod tie and fittings, and SA 350 grade LPF and LPF2 forging for low temperature service. API 5L is for various grades of pipes. Before we discussing the F numbers, we will make a summary of P number, F number, and G number. So B PVC code, that means ASME boiler and pressure vessel code, has assigned certain numbers to base materials to be welded as well as to the filler materials, that is electrodes. For base materials, ASME has assigned two number system, that is P numbers and group numbers, and for filler materials there is a system which is assigned as F numbers. And for the welded metal composition, that is chemistry mixture between the base material and the filler material of the final weldable, that is P number plus F number. The number system which is assigned is A number. So these numbers can be found in the ASME PWC Section 9, Table 1. That is P number for base material, that is QB422, group number for base material QB422, F number is 432, and A number is 442. So A number that we discussed there is the weld metal composition, and the F number is filler material or electrode, and P number and group number for base material. So this is a symbolic representation: P number for base material, F number for filler material, A number for welded metal composition. So base metal grouping P number and group number is for to reduce the number of procedure qualification records. So conducting a procedure qualification requires a lot of time and money due to procedure requirements, that the preparation of weld equipment, welding of test equipment, and sending it to a lab for destructive testing, etc. To reduce this costly and time-consuming activities, ASME has done grouping of the base material and assigned certain P numbers to each group. This group of results done on the basis of following parameters: material composition, weldability, and mechanical property. So all materials of the P number does not exhibit same properties, but after considering above parameters as well as a logical reasoning, why is grouping is required? If we change the base material from the existing qualified WPS, and if a new material falls in the same P number, then the requalification of existing WPS is not required. It means no need for a new PQR. But does not mean that one can easily substitute base material from an existing WPS of same number at any time. Whenever there is a change in the base material from the existing WPS, compatibility can be considered with regard to following factors: metallurgy property, mechanical property, design considerations, service requirements, and heat treatment. So actually P number 1 is for carbon steel pipes. So these are the P number range. P number 1 to P number 15, F is for steel and steel alloys, and the 21 to 26 aluminium and aluminium base alloys, and 31 to 35 is the copper and copper base alloys. 41 to 49 is for nickel and nickel base alloys. 51 to 53 is titanium and titanium base alloys. And 61 to 62 is zirconium and zirconium base alloys. That's about the P number. Now that we understood the P numbers, let's move on to group numbers. Group numbers are subset of P numbers assigned to ferrous based metals. Group numbers are assigned group numbers are assigned only to those materials which require toughness testing for the qualification of its WPS. So we can find out the P number and group number of any material from the table QB422 of ASME Section 9. Some more valuable information like minimum centration, the UNS number, normal composition product form also determined from the same table. For example, SA 516 grade 65. It is page 140 of manual calculation is 65 KSI. P number 1, group number 1, UNS number Okay, what is UNS number that we have to see? Natural composition, carbon, manganese, silicon. Typical product form is plate. This table is shown here. Table, it is the ASME Section 9. In this one, page number 192, we have this specification number, designation grade, EMS number, minimum specified tensile strength, E number, group number for welding, T number, AW is T number for bracing, ISO 160, this model combination typical product form. So we are using X52 API file X52. This one is a minimum specified tensile strength is 67. It is for 60 PA. P number and group number is 1. And typical form is seamless and welded. So another grouping of base material was S number, but does not be used nowadays because it was assigned for those materials that are acceptable for use by the ASME B31.3 for pressure piping, or they selected the boil and pressure vessel both cases, but are included in section second of okay. Base material that was previously assigned as number was reassigned as one with P numbers or P numbers and group numbers. Then we will come to the F numbers. F number is meant to reduce number of welding procedures and greater performance qualifications. It is this basis of this F number grouping is a usability characteristics. Usability characteristics is fundamental and the ability of a welder to produce solid welds with a given filler material. Hence, is such if a welder can make a satisfactory welding with a particular filler material, he will be able to weld with all filler material belonging to a particular F number. If a particular welder is a regular welder can also has a factory weld with a particular filler material of a F number dash, then he will be able to weld with all the filler materials with a belonging to that F number factory. So F numbers of different weld filler materials are steel and steel electrodes, F1 to F6, aluminium, copper, like that it is there. So F number grouping does not imply that one can substitute filler material from the existing WPs or saving at any time. Whenever there is change in the filler material from the existing WPs, compatibility can be considered with regards to following factors like metal using property, mechanical property, design, service, heat treatment, etc. Now the A number, that is a filler plus base grouping. It is for the weld composite material. It is another type of classification is A number, which determines the chemical composition of the deposited weld material. So there is a deposited weld material. This physical, there is a physical chemical composition, and this chemical composition determines the A number. A number is always the resulting properties of this welded material. This A numbers are assigned. To find out the A number, we need to know that what the welded material is made of, that is the chemical composition of the welded material. This includes mixture of chemical properties of base material and the filler material. So it is a table AQW442. This table shows the different find the A number. First we need to what the welded deposited weld material is made of. Chemical composition. It includes mixture of the chemical composition of the base material and the filler material. So we have this table shows different chemical composition of the welded material. Find the raw in the table that matches the chemical composition of the welded material. A number is listed on the left side of the same row. So this is the table. This is the table 441 QW 441 A numbers. So here what is happening? So if it is carbon, chromium, molybdenum, nickel, magnesium and silicon. If it is coming this one, it is a type of welded material is mild steel, and therefore the A number will be 1. Like that. Our API 5L X52 and the filler material E6010 and the E7018 are coming in the deposited materials coming as A number as well. So particularly it reveals the chemical composition of a deposited welded material. Okay. So in the slides we have this D number, group number, ASTM algorithm. Now we go to the next slide, that is why use API 5K. Go back to our web page. What is F number of E6010? F number of E6010 is 3 according to section QW EX11. So F number is 3. F number is assigned to cellulose coated electrodes known for their deep penetration, strong arc force and suitable for all position welding, especially vertical down and root passes in the pipe welding. Other electrodes in these groups are include E6010. So this E010, what is E6010 means? Now we discuss electrode classification in the next video.